I can start. Feel free to ask questions. There will be some points where I will kind of expect questions, or at least I will like some feedback, because I think I have more questions than I have answers for this talk, which is kind of unusual. I like to explain things, and this time I'm more like, I have a lot of questions, and there's a lot of smart people here in the mapping community, and maybe I can ask them to you, and maybe you can give me answers I can use. So this talk is commoditization and programming languages, and it sounds really fancy, but in the end, everything starts with a very easy question. Let me move forward. I need to be in the correct window for that to work. I'm Ruben. I'm actually a mathematician, but I have been working as a data engineer for, I think, 10 or something years. And I've been working as a lead data engineer for a couple of years already at a small ad tech agency called Hybrid Theory. I've been writing mostly, a bit of everything. I started with Python a long time ago. Then I started doing some Go, and I've been writing a lot of Scala for the past, big data, Scala, Spark. It happens. I happen to really like it. I'm writing less code now that I'm more of a lead role, but well. And this is kind of the first question that you may have. I'm a data engineer in the end. I may lead people, but why am I talking here about strategy and languages? So last year, I discovered Wardley mapping, and I found it fascinating because I really like things that challenge assumptions and make you think. And I see Wardley mapping and the idea of mapping in general as a tool for thought, which is it's a concept that I think Michael Nielsen is one of the first to talk about. He's working at Google, if I remember correctly. And my approach for mapping is that I try to challenge the access, like the last part of what Simon was showing in his presentation before. So what problem spaces can we try to solve by, putting some access and drawing and discussing and getting to the grid of it. So, we've had already a really nice presentation by Simon, so I won't get into mapping per se, but I will kind of get you in the mood for some mapping. Because I like to, as I mentioned, I like to think of mapping as a new way of seeing things. And I like to give a few examples that maybe they don't make sense, but they make sense for me. So these are two Cubism paintings I happen to like. The goal of Cubism was to depict an additional dimension in a flat representation. So the left side one is the new descending staircase, which is representing time. So it's supposed to be the flow of time when the nude is walking down. And the girl with a mandolin, it's a representation of several sides at the same time. This is supposed to stretch your mind and make you see things that you haven't seen before. That's what mapping is for me. The same can be said about Ishikawa diagrams, which are used to analyze 5 whys issues, explain processes. Feynman diagrams, the same. Before Feynman diagrams, the kind of calculations you could do in quantum physics was super complicated. After Feynman diagrams, they were, not easy, but you had a way of talking that was super quick. And he got a Nobel Prize about that, so it was pretty good. And you have the periodic table, and here it's something that I think it's underrated. When you have a Wordley map and something evolves, that leaves a hole that then can be fit with something. That's something that the periodic table also had. So Mendeleev could imagine, so he could forecast what I think germanium and gallium were going to be even before they existed in the known reality for humans, which is impressive. And that's what I think mapping offers us, a way of seeing into the unknown. There's the famous quote by Donald Rumsfeld that we may take as a joke, but I think for software engineers and everybody here, it should be very important. And there are unknown unknowns. We may know what we don't know. So, for instance, I don't know anything about, I don't know, COBOL. Well, not COBOL, I know it. I don't know, jewelry. I know nothing about that. But there are things I don't know, and that's the ones that are dangerous. And knowing there are these holes in knowledge is very important. I think mapping helps us with that, because they allow us to talk with other people, and they can easily point out what are the flaws and the holes that are appearing there. So let's get a bit into Wardley mapping. And if you remember the usual, the talk we had before with Simon, he likes Themistocles. I like something a bit more, well, it was a far time ago. So, what happened between this and this? You may think this looks familiar. Well, it was not the force. That may help, but in the end, it's a tool. You need maps and you need plans. Without a map, you can't really have a plan. So, I will leave the SWOT diagram of the Star Wars trilogies as an exercise for the watcher. But what is the problem I was going to analyze in this talk? It all started, I think it was 3 months ago. And beware, these are not the kind of Wardley maps you may expect. I tried to twist the axes and explore new problem spaces. So it's like, we may not know what's in the X, and we may not know what's in the Y, and that's what we are going to try to do. So I tried to answer this question. What's the landscape? And let's start with climatic patterns of programming languages. And I had no idea about how to tackle that. This question rose because Dropbox a few months ago, I think it was in April, May, March, it was very early in the pandemic, announced that it had moved the backend of the sync service in the desktop client from Python to Rust. And well, as a Python developer, I was like, Dropbox are one of the largest Python users in enterprise. What does this mean for me as not only a Python user, but a Python developer and a Python hiring manager? So I hire people that know Python. Can this affect my future and the future of people I hire, the future of the market? And I started trying to think what this meant. And this led to, what's the landscape for a programming language? And well, I had no idea. The question is way too large to answer. So the first one, it's like, what are the axes I would like to use? We have no bearings, so it's like we don't have a map because we don't know where we are. We could call this a form of situational awareness, so where we are. So I started as this is something my PhD advisor always told me. Try to pick an example problem, play with that, and then try to solve the real issue. So I thought, okay, I want to see what are the extremes. Let's see what are the 2 extremes of a programming language. I pick a couple of them to see what I could imagine. So languages start, usually, at least, there will always be counterexamples to whatever I say here, and I'm aware of most of them. But languages usually start as a just created toy, experiment, or idea. For instance, Python started as a programming language that evolved from a teaching language. It was used to try to teach better. It was a replacement for BASIC. It improved on that a lot, but that was the initial idea. Haskell started as an investigation in lazy functional languages. Scala started as a try to mix the best of both worlds of object orientation and functional programming. Then we have Java that, well, started as a kind of enterprisey thing, but it had a start, and it was an idea. Then we have the other extreme. This would be close to what I would think about a commoditized. It's everywhere. So you can use it everywhere in the stack, not counting. When I say stack, I'm a bit wary because there are languages you can't use in frontend. So I would separate it. When I say stack, it's more or less the backend stack. So you can use them in machine learning, in robotics, in AI, in almost anything. Also, the language stops being kind of shiny in your resume. It's like, well, you may not be expected to know language X, but if you have, I'm an expert in X, it doesn't look weird. It's like, okay, you are an expert. We are happy with that. That's what I will think is the other extremes. I would think these are the two sides in the x-axis, so to say. But okay, let's try to draw that. I don't know how well you can see this because sometimes my drawings are a bit smoky, I don't know, a bit thin. But in the x-axis, I have stages of evolution. I didn't want to add any other separation, but it would be what I just mentioned. And in the vertical, I wrote first idea. Proximity to user was 1, and then stack span, which I will get to in a few slides. Yep, Oliver is mentioning a really good point that I think I will get into that after a few slides, because I also think this is an important one. So I'm placing Python and Haskell here in this kind of landscape-ish. And the vertical alignment, it's because of, okay, one is didactic and the other one it's less didactic. So a user would be more likely to see Python than what it was going to be to see Haskell. But when we move from the 90-somethings to the 20s, Python is on the other side, and it's almost everywhere. This is where I think that stack span may be a good vertical axis. So when a language starts, it's like really narrow. It's focusing on a problem, a specific thing that it's trying to solve the best. And eventually, I think this is what could be the first climatic pattern that I suspect it's in the landscape, even if I'm not sure what the landscape for a programming language is that the programming language tries to grab as much of the available problem space as possible. So even languages that are not that commoditized, like we could argue how apt Haskell is, but obviously the amount of Haskell developers, Haskell market opportunities, and Haskell using companies, and etc. And I'm not picking on Haskell. It's a language that I just happen to know enough to be vaguely dangerous, so it's why I'm using it. It's nowhere near Python. But if you have a look, Haskell can be used for services as well. It has a really performant backend systems. It's used for data manipulation. It can use for machine learning and deep learning, AI, robotics, Internet of Things. It can use for almost everything. So what's the difference between these two? I mean, how could you place them vertically differently? So I got here and I got stuck because I couldn't answer my questions with this diagram. So I started again, okay, what does commoditization mean? And this goes a bit into what Oliver is mentioning, I suspect. Maybe if we think that these two extremes are genesis and commodity, we get back to what is commodity? Who is the user? Because you can't have a commodity really if you don't know who is commoditizing what. What are you exchanging? I mean, for me, a commodity is something that can be relatively easily exchanged, and there's enough market that it's not painful. So we have compute now. I mean, if you are Amazon Web Services user, moving to Google Cloud is possible. It may be painful, but it's like compute is in the end a commodity, so you can change them over relatively, as Eric says, it's high fungibility, so you can easily exchange them. I mean, it may not be super easy, but the possibility is there. If you are a user of AWS in, I don't know, 2007, you may not be able to exchange it with anything else. That was not a commodity unless you wanted to have your own rack in your basement. So, okay, who is the user of a programming language? It may be the company that is choosing the language because they are users. So when a company starts, CTO may decide, okay, I'm going to pick this language because it has a certain set of frameworks and libraries. It may be easy to solve my business problems with it. It may be easy to hire. I may be familiar with the language. Many options, but it's a company choice. On the other hand, a developer may choose the language. I mean, we all come with a baggage. So I was taught C. A lot of people were taught Java. At some point, everybody's being taught Python in university or courses. But if you are free to choose, the developer is the one that chooses the languages, and usually a reasonable amount of developers learn a larger amount of languages. So we may have these two options as different commodities, and they can shape the landscape in different ways because they are not opposites, but counterpoints. So a commodity for the company can be either that you have a large pool of talent, so it's easy to hire or relatively easy to hire, and that you have a varied pool of talent. So you can't only hire beginners because the language is too new, or you can only find people with 10 years of experience because that's not good, because you may want to hire a few seniors and a few juniors because of budget constraints or whatever. Yeah, but coevolution, I think it could be too hard to analyze because I still have issues with the model I propose here. So Oliver is mentioning in the chat that there's a C option. It's the coevolution of a language with a different component that gets adopted. So the kind of symbiotic relationship of Objective-C and the whole Apple ecosystem, or Swift, for instance, now, or a bit Go and the emergence of Kubernetes and Docker that are kind of evolving at the same time altogether. That's an additional one that it would be like, okay, if A and B are already too complicated, this C option, it's like, whoa, I don't know how to analyze this. If we switch to the developer side, what's a commodity for the developer? As a developer, what do I want to find easily? Well, I may want to solve a large range of problems because if you can only use a hammer, well, if you run out of companies that need to place nails in wood, you are out of job, and usually that's a bad state of affairs. And with a large demand, and that's interesting because, I mean, I may prefer a language that has a huge amount of demand, but the company also wants a language that has a huge amount of offer. How do you balance these two issues? So what's this? A feedback loop because a lot of demand in the market generates a lot of offer? Or it's a deadlock because how does a language become a commodity enough that companies can pick it up? So I started thinking, okay, how can I analyze this one? I focused on Python because it was the easier one, because it was recent enough that the story was not tied with other things I will mention in a few. So Python started as a teaching language, so it was taught to some students. Easy. These students had learned a new language that was relatively nice. They started solving small problems, which increased the usage. As usage started to pick up, I left it there. As the students were taught this language, some of these students went on to have doctorate degrees, go into numerics. This was the kind of the start of NumPy and Pandas. So they were like wrappers around Fortran and C libraries. This increased usage again. So it was like for investigation of numeric things. As usage picks up, there's more availability for teaching because if the industry is starting to use something, it makes more sense to teach it more. And if other parts of the department are using it for the internal things they are doing, in the case of numerics, it makes sense to teach it to other people. So it was expanding. As teaching picks up, there are more students. As more usage, you start to bring the language into more things. And a lot of feedback loops start to emerge. And I thought, oh, this is interesting. I mean, this may explain why Python is like as popular as it's now, or it could even explain Java. I mean, Java was also a really big teaching language. It had the push of the industry as well at some point. But is this the whole of the story for the feedback loops? And I thought, well, maybe. But next slide. This can't really be the question, the answer. And this is where I start having more questions than answers because I thought, okay, teaching sounds like a good explanation. But then you start thinking, okay, Haskell was also used as a teaching language from the late 90s and until now. It's used for teaching type theory and introductory programming as well. Lisp was used from the 70s to the 90s as the starting language in a lot of universities. What prevented these feedback loops from emerging? I have a suspicion that it's related to complexity, but I'm not sure. And here is where I start to have questions that I would like answers to, and I can't. So what drives the adoption feedback loop? Because teaching is helpful, but there's something else, because we have the counterexamples of Lisp and Haskell that are preventing teaching to be a good explanation. We have against Lisp that computing power was not as prevalent in the 70s, 90s for Lisp, which was not that fast until some compilers in the late 80s. Also, there were less computing resources available for people at home. That could explain that one. Then we have Haskell, that it's a kind of a complex language, and it wasn't as performant until relatively recently. But I think complexity may be the one that prevented this, but I'm not sure. I mean, Java is easy, but it's not that easy. C was a teaching language at some point as well, but it didn't catch on as much as Java or Python. Well, I mean, most of the programmers at some point were C programmers, but that quickly gave rise to Delphi, Pascal, and a lot of others. What other climatic patterns we could find? I mean, I'm pretty sure that the stack expansion, it's a clear one. I mean, I suspect that any language that eventually evolves to be any useful tries to reach anything. Everything. And this is kind of, I think it's totally natural, because if you enjoy a language as a developer, you want to use it for other things. And as soon as you want to use it for other things, you try to force it to be used for other things. And then, well, you get really funny things like web servers in PostScript because people like PostScript. There are some weird people or really strange abominations, but then you also get TensorFlow for Scala, and I don't know, there are I think there's a TypeScript API for Spark, or TypeScript or JavaScript, one of those. And this is one I can't find easy examples that are recent enough to be able to show something, how the programming languages decay. So, I mean, Simon mentioned in his talk, I mean, industries eventually become the new legacy. But I don't think there's any language that has been created in the last 20-ish years that got to prominence and fell down quick enough that we can say, okay, languages decay because this, and this. So this is something that maybe we will start seeing in the 10, 20 years to come. But I don't have examples. Yeah, Oliver is mentioning Perl. Yeah, that's a good one. I don't know enough Perl to know, but Perl 6 was released last year, right? COBOL, Eric is asking how old is COBOL. I think COBOL it's 50-ish years, if not 55. It's from the late 60s. So I don't think it counts. I mean, I would think more, Perl would be a good question about why and how it decayed. Yeah, I will write this one down because I will investigate this one. But I think it's Perl 6, the last version, or 7. It was released like, I don't know if 1 year ago or pretty recently. But Pavel is mentioning that, well, we had a really, really large release cycle with Perl 6. That's what I remember, that when I was starting programming after math, I had a look at Perl because it was kind of, it was not all the rage, but it was useful enough. And I was like, whoa, this language is horrible. But we are going to improve it so much in Perl 6, and that was like 16 years ago. I mean, I think they were already talking about 6 before 5 was fully released. Yeah. So Pavel is adding that more than 10 years, and people eventually lost their patience, and the world moved, and well, we are now in the realms of, that's my comment, that now we have a lot of other languages that can take the place of Perl. Like, I mean, we have Python, that it's kind of the winner in a lot of areas, but we have also Go, well, maybe not Rust, but for scripting, what we would have that would replace Perl, because in the end, Perl was partially replaced by PHP technically, because when we had CGI, PHP became easier, and probably that removed a lot. And for scripting, I would guess Python started eating that area. Yeah, Ruby. Ruby ate a lot of the scripting capabilities, and then Python removed Ruby a bit. Yeah, and here is where I get to the questions part that we stop here. I have a lot of links at the end of the talk, and as I mentioned, this is kind of based in a talk I gave last year that you can find in my GitHub. If you go to my GitHub, I haven't posted the languages for this the slides for this one yet, but there are the slides for the previous one, which was the repository called mapping. And that was the initial thoughts I had about how languages evolve. And it was more of a personal exercise of what I want to try to learn given the behavior of the landscape of languages. So for instance, if Python is going to win on the big data ecosystem, Dask may be the framework of choice instead of Spark. It's a big if, because Spark at the moment it's way larger, but it may mean that I will need to keep an eye. That was the kind of questions I had last year. And this year I wanted to go one level higher and think about the language instead of the frameworks that go together with the language. But that plays with, I think it was Oliver who mentioned that the frameworks are important for the adoption. And I think that's super important, because in the end, you don't care about the language. You can do anything in any language. It may be better or worse. It's more about the framework and, of course, about the people that you can find. I mean, and what else I wanted to say? So if I go back, sorry. I think, well, that was a half an hour, which I think it was the time allotted, but I don't know if I can invite people to talk, to join the stage and ask the questions. I thought that was an option, but I don't know where it is. You can, so as a person, you can do that, and then ask the question or come together and try to answer the question. I mean, I think I have more questions than you have.